Good morning, students. Move on to the next question. Fourth one. Derive rho is equals to n e square tau divided by m. So ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್. ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಇಂದ ಬರುತ್ತೆ. ಸೊ ತುಂಬಾ ಸಲ ರಿಪೀಟ್ ಆಗಿರೋ ಕ್ವಶನ್ ಕೂಡ ಇದೆ, ರೈಟ್? ಸೊ ದಟ್ ಮೀನ್ಸ್ ಕಂಡಕ್ಟಿವಿಟಿ is equals to n e square tau divided by m, right? So for that, consider one conductor of length L and area of cross section A. So first we need to consider one conductor of length L and area of cross section A. So this conductor is subjected to the external electric field. That means we are connecting this conductor to a battery, right? So battery means external source, right? So electric field, when we connected this conductor to the external source, so the current is flowing in the conductor, so that current is I, right? So electric field is in the direction that is from positive terminal to the negative terminal, right? So conductor consists of the electrons. That means electrons are the charge carriers. So these are moved in the opposite direction with respect to the current, right? So electrons ಯಾವ direction ಅಲ್ಲಿ move ಆಗುತ್ತೋ, so ಅದಕ್ಕೆ opposite ಆಗಿ current flow ಆಗುತ್ತೆ. So these will move in the velocity. So that velocity is the drift velocity, right? So drift velocity is nothing but the velocity. So velocity is a vector quantity, electric field also vector quantity, right? So now volume of the conductor. So volume of the conductor, that is, it is in the cylindrical shape. So length into area, right? So that is A into L. Next, total number of electrons in a unit volume. So first now we can find the volume of the conductor. So volume of the conductor is given by A into L, right? So next, E volume alli ಎಷ್ಟು electrons present ಇದೆ ಅನ್ನೋದನ್ನ first find out ಮಾಡ್ಕೊಳ್ತೀವಿ. So there are number of electrons which are present in the unit volume of the conductor. That is the total number of electrons in an unit volume, right? So that is equals to n into E, right? So number of electrons in an unit volume, that is n into volume, that is n into area, right? So total charge of these electrons. So from the first chapter, right? So total number of charges, we have the relation that is Q is equals to n into E, right? So here also we are finding the total number of charges which are present in this volume, right? So that we take the Q is equals to N A L into E, right? So this we can take equation 1. But current flowing in the conductor, right? So but current I, that is equals to rate of flow of charges per unit time. So again this is from the definition of the current. I is equal to Q divided by V, right? We have the value of Q, so substituting the value of Q, that is N A L into E divided by T. So this is from equation 1, right? So as the electrons are moving within the length L, so E length the electrons move ಆಗ್ತಿದೆ with the velocity Vd. Again from the definition of the velocity, velocity is equals to distance or displacement divided by time, right? So here the velocity is Vd, that is the drift velocity, and the distance is L, the time is T. So L by T we can write that one as Vd, right? So in this relation we have L, that is divided by T. So we can replace L by T, that is equals to Vd, right? So I is equals to NAE Vd, right? So that is because Vd is equals to L divided by T. Now we know the relation for the Vd, right? Or we can shift A to the LHS, so that we can write I divided by A, that is equals to NE into VD. So we have the formula for VD, that is E into E divided by M into tau. So where tau is the relaxation time. And again, I by A, current flowing per unit area, we call that one as the current density. So that current density is denoted by capital J, and that J is also a vector, right? So I by A na naven barkobodu, current density anta barkobodu, right? So that is J, that is equals to, so multiplying this terms, N E square tau divided by M into E, where E is also the vector, where E is the electric field. E vector ಇದೆ, drift velocity vector ಇದೆ, and current density ಕೂಡ ನಮಗೆ vector ಇರೋದ್ರಿಂದ, so these we can represent in vector form, right? So N is constant, E is constant, mean relaxation time is constant, and mass of the electron is also constant. So we can replace this with the constant rho into sigma into E, right? So from this we can write, therefore sigma is equals to Ne square tau divided by M. So this one is the final derivation, right? So tumba important, simple ಇದೆ, but 5 marks ಗೆ ತುಂಬಾ ಸಲ ಕೇಳಿರೋ derivation ಇದು, right? So next, fifth one, obtain the expression for effective EMF and effective resistance of two cells connected in parallel and series. So idu kuda important. So last one supplementary series parallel ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. So ಕೆಲವು ಸಲ series ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಕೆಲವು ಸಲ parallel ಕೇಳ್ತಾರೆ, right? So that means we need to find the effective cells, right? That is in the resistance and also cells in the combination. So ಒಂದು series ಇರುತ್ತೆ, ಇನ್ನೊಂದು parallel, right? So starts with series. So series, consider two cells of EMF E1 and internal resistance R1, right? So these two are connected in series. Another cell of EMF E2 and resistance R2, where I is the current flowing in the cell, right? So taken A, B and C, right? So potential across VA and VB. Potential across the cell E1, right? So potential across the cell E1, we can write that one VA minus VB, that is equals to E1 minus I R1, calling this one as first equation. So in between 2 points only, now when find out potential, again we have the relation V is equals to E minus IR. So in the derive relation, so say we are going to substitute here, right? So potential V is the potential difference between A and B, and in place of E we are written E1. So I is the common current in series and R is the internal resistance of cell 1, right? So adike R1 anta barkondiddhi, right? So next, potential difference across cell E2. So between B and C, so right, that is VB minus BC, that is equals to E2 minus IR. So taken this one as second equation, right? So but we need the total potential difference between VA and BC. So these two cells which are connected in series, so we need to find the total potential difference between the 2 points, that is A and C, right? So potential difference between A and C. So potential difference between these 2 points means, so ಇಲ್ಲಿ ನಮಗೆ ಎರಡು ಸೆಲ್ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ. So So between A and C is nothing but the potential difference across the series combination. The combination of ಎಷ್ಟು voltage ಬರುತ್ತೋ ಅದು ಯಾವುದು equal ಇರುತ್ತೆ ಅಂದ್ರೆ potential difference between A and C ಗೆ equal ಆಗಿರುತ್ತೆ, right? So this again we can write VA minus VC, that is equal to, so adding and subtracting VB to the relation. So VA minus VB na another form ಯಾವ ತರ ಬರ್ಕೋಬಹುದು, VA minus VB plus VB minus VC, right? So minus VB plus VB cancel ಆಯ್ತು, again we are getting VA minus VC. So LHS ಅಲ್ಲಿ ಏನಿದೆ ಅದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. So VA minus VB we can write this one, and VB minus VC we can write this one. So again from the equation 1 and 2, right? So VA minus VB, E1 minus IR1 plus E2 minus IR, right? So this we can write VAC. So VAC we can write VA minus VC, right? So separating E1 plus E2 minus I taken common R1 plus R2, calling this one as third equation, right? So this combination is equal to, so single cell which works same as the two cells which are connected in series. So ಇದು ಯಾವುದು equal ಇರುತ್ತೆ ಅಂದ್ರೆ some other cell ಗೆ equal ಇರುತ್ತೆ, so that cell we taken as equivalent. So equivalent is the cell, equivalent cell of the combination of these two cells. That means ಈ ಎರಡು cell ಏನು work ಮಾಡುತ್ತೋ, so same work done by the another cell, so that we name given as equivalent, and its internal resistance is R equivalent, right? So here we have A, C, and I is the current flowing through the cell, right? So again the potential difference across the equivalent cell A and C. That means points A and C ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು, ಅಥವಾ ಈಕ್ವಲೆಂಟ್ ಸೆಲ್. ಇಲ್ಲಿ ನಮಗೆ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟಿರುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರ್ಕೋಬಹುದು, right? So again here VA minus VC, that is equals to, from the formula in place of E we can write E equivalent minus I is the current flowing through the equivalent cell into R equivalent, right? So calling this one as fourth equation, right? So ಇಲ್ಲಿ ನಮಗೆ third equation ಮತ್ತೆ fourth equation. So VA minus VC we can write that one as VAC, right? So comparing equations 3 and 4, or from equations 3 and 4, right? So ಎರಡು equation ಅಲ್ಲಿ LHS ಏನಿದೆ ನಮಗೆ ಸೇಮ್ ಇದೆ, VAC again VAC. So we can directly equate the RHS. So E equivalent minus I or equivalent, that is equals to E1 plus E2 minus I into R1 plus R2, right? So in place of E equivalent we have the summation of two cells, right? So therefore E equivalent, that is equals to E1 plus E2, right? So in place of I we have I as it is. So in place of R equivalent we have R1 plus R2, right? So R equivalent, that is equals to R1 plus R2. So this one is the final expression for the relation. That means we find the equivalent cells in series and also equivalent resistance in series. So adunne namage question alli kelirodu, right? Obtain the expression for effective cells, that is effective EMF of the two cells, or effective EMF, and equivalent resistance or effective resistance, right? So series ತುಂಬಾ easy ಇದೆ. So simplification ಅಲ್ಲಿ ಈ ಪಾಯಿಂಟ್ಸ್ ಗೊತ್ತಿರಬೇಕು, that is again by using the relation. So ಈ relation ಗೊತ್ತಿತ್ತು ಅಂದ್ರೆ ಈಸಿ ಆಗಿ ನಾವು ಸಾಲ್ವ್ ಮಾಡಬಹುದು, right? So 5 marks ಗೆ ಪ್ರಾಕ್ಟೀಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. So ಇದು ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್. So ಎಲ್ಲ ಕಡೆಗೂ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. ಫಸ್ಟ್ ಬಿಟ್ವೀನ್ ದ ಫಸ್ಟ್ ಸೆಲ್, and next between the second cell, and the third step is between the two cells, so that we can take VA minus VC, right? So ಇಲ್ಲಿ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಇದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ, so adding and subtracting VB, so from equations 1 and 2, right? Here we can write from 1 and 2. So ಸೊ ಎಲ್ಲ ಕಡೆಗೂ ಇದನ್ನ ಬರೆಯೋದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಸೊ ಯಾವ್ದ್ರಿಂದ ಯಾವ ರಿಲೇಷನ್ಸ್ ನ ನಾವು ಡಿಫೈನ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. So next, two cells in parallel. So again considering two cells, one having EMF E1 and internal resistance R1, and it is connected to the another cell of EMF E2 and internal resistance R2. So series alli namage current same ittu, right? So here we taken A, B1, B2 and point C. So here is the current flowing I. So parallelly current enagutte namage divide agutte I1 and I2, right? So again here I1, I2, so we getting the current I. So this is equals to the equivalent resistance, equivalent cell. Idu yavudku equal irutte andre one cell ge equal agirutte. So this works as similar to that of the two cells, right? So again by the same procedure, first we need to find the potential across E1 and potential across E2. So but parallel in condition irutte andre potential across E1 ಎಷ್ಟು ಇರುತ್ತೆ, potential across E2 ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ same ಇರುತ್ತೆ. So this is the condition in parallel. So parallel ಅಲ್ಲಿ potential same ಇರುತ್ತೆ, current divide ಆಗುತ್ತೆ. But series ಅಲ್ಲಿ current same ಇರುತ್ತೆ, potential divide ಆಗುತ್ತೆ. So that's why we taken V1 and V2 in series. So ಇಲ್ಲಿ directly we can take V, right? So potential difference across the cell E1, right? So across the cell E1 potential same irodrinda we can directly take V, right? So V is equals to E1 minus, but current is I1, right? So I1 R1. I1 R1 is the internal resistance and the current flowing in the cell E1, right? So taken this one as first equation, right? So next, potential difference across the cell E2. So across the cell E2, illi kuda namage potential enirutte same irutte. So that's why we can take V is equals to E2 minus I2 R2, right? So taken this one as second equation, right? So but current I is equals to I1 plus I2. So current ಏನಿದೆ ನಮಗೆ I ಇದೆ. So ಎರಡು ಬ್ರಾಂಚ್ ಅಲ್ಲಿ ಡಿವೈಡ್ ಆಗ್ತಿರೋದ್ರಿಂದ I1 ಮತ್ತೆ I2. So ಇಲ್ಲಿ ನಾವು Kirchhoff junction rule ಅಪ್ಲೈ ಮಾಡೋದು ಕೂಡ ಸೇಮ್ ಬರುತ್ತೆ. So input current is equals to output current. So I is equals to ಎರಡು output ಅಂದ್ರೆ ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇರೋ current, right? So I is equals to I1 plus I2, right? So from equation 1 to we need to substitute the value of I1 and I2, right? So from this we can write I1 is equals to E1 minus V divided by R1. So again from the second relation we can write I2 is equals to E2 minus V divided by R2. So calling this one as equation 3, equation 4, right? So this one as equation 5. So substitute equation 3 and equation 4 in equation 5. So LHS I is equals to E1 minus V divided by R1 plus E2 minus V divided by R2. So it is the next mathematical simplifications, right? So we can take E1 by R1 plus E2 by R2. We can take minus V common. So from that 1 by R1 plus 1 by R2. So in lectures we have I cast this, right? So I is equals to, we can take LCM E1 R2 plus E2 R1 divided by R1 plus R2. R1 into R2. So E ಎರಡು ಟರ್ಮ್ ಅಲ್ಲಿ LCM ತಗೊಂಡ್ರೆ R1 and R2 becomes the LCM. So E1 R2 R1 E2 divided by R1 R2. So minus V as is. So in these two terms, we can take LCM R1 plus R2. Again, here we getting R1, R2, right? So multiply this equation, whole equation by R1, R2 divided by R1 plus R2, right? So in complete equation now, we need to multiply by the term R1, R2 divided by R1 plus R2, or you can take this one as the reciprocal. So iduna shift madidre ee kade barutte. So we need V, right? So ಎರಡು ಮೆಥಡ್ ಅನ್ನು ನೀವು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. So easy ಅಂದ್ರೆ multiplying with the term R1, R2 divided by R1 plus R2. So ಇದನ್ನ ಏನಕ್ಕೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಿದ್ವಿ ಅಂದ್ರೆ ನಮಗೆ ಓನ್ಲಿ V ಟರ್ಮ್ ಬೇಕು. ಸೊ ಇಲ್ಲಿ ಈ ಟರ್ಮ್ ನ ನಾವು ಕ್ಯಾನ್ಸಲ್ ಮಾಡೋದ್ರಿಂದ ಸೊ ಇದಕ್ಕೆ ರೆಸಿಪ್ರೋಕಲ್ ಆಗಿರೋ ಟರ್ಮ್ಸ್ ನ ಡಿವೈಡ್ ಮಾಡಬೇಕು, right? So we get I into R1 R2 divided by R1 plus R2. That is equals to E1 R2 plus E2 R1. So ಇಲ್ಲಿ R1 R2 get cancel, R1 plus R2 minus D into, so ಇಲ್ಲಿ complete term ನ multiply ಮಾಡಿದ್ರೆ ಎಲ್ಲ ಟರ್ಮ್ಸ್ ಏನಾಗುತ್ತೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, we get only the V, right? So shifting to the LHS, V is equals to E1 R2 plus E2 R1 by R1 plus R2 minus I into R1 R2 by R1 plus R2. So forming this one as sixth equation. So again, by the equivalent circuit, we have the relation, that is potential difference between the equivalent cell or equivalent EMF or equivalent cell. So we have the relation V is equals to E equivalent minus I R equivalent. So calling this one as seventh equation, right? So from sixth and seventh equation, from 6 and 7, so LHS ಅಲ್ಲಿ ಎರಡು ನಮಗೆ ಪೊಟೆನ್ಶಿಯಲ್ ಸೇಮ್ ಇದೆ, ಸೊ RHS ನ ಈಕ್ವೇಟ್ ಮಾಡ್ಕೊಂತೀವಿ. So E equivalent minus I R equivalent, that is equals to E1 R2 plus E2 R1 by R1 plus R2 minus I into R1 R2 divided by R1 plus R2. So ನಮಗೆ ಬೇಕಾಗಿರೋದು ಯಾವುದು equivalent and R equivalent. So EMF of a cell equivalent and internal resistance of a cell, that is equivalent. So LHS RHS equal ಆಗಿರೋದ್ರಿಂದ in place of E equivalent we have this term, so we can write E equivalent, that is equals to E1 R2 plus E2 R1 by R1 plus R2. So I as is I ಅಲ್ಲೇ ಇದೆ, so R equivalent, that is equals to R1 plus R2 divided by R1 plus R2. So this is what the final expression. So series compare ಮಾಡಿದ್ರೆ parallel ಸ್ವಲ್ಪ lengthy ಇದೆ, right? So ಅಲ್ಲಿ ನಾವು ವೋಲ್ಟೇಜ್ ಸೇಮ್ ಅಂತ ವೋಲ್ಟೇಜ್ ಡಿವೈಡ್ ಆಗ್ತಿರೋದ್ರಿಂದ ನಾವು ವೋಲ್ಟೇಜ್ ಇಟ್ಕೊಂಡು ರಿಲೇಶನ್ ಫೈಂಡ್ ಮಾಡಿದೀವಿ. ಇಲ್ಲಿ ಕರೆಂಟ್ ಡಿವೈಡ್ ಆಗ್ತಿರೋದ್ರಿಂದ ಕರೆಂಟ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಈಕ್ವೇಷನ್ಸ್ ನ ಡಿರೈವ್ ಮಾಡಿದೀವಿ. ಬಟ್ ಯಾವುದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡೋದನ್ನು ಇಂಪಾರ್ಟೆಂಟ್ ಯಾವುದು ಅಂದ್ರೆ potential difference across the cell and potential difference across the second cell, right? So ಈ ಎರಡು ರಿಲೇಷನ್ಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, right? So practice important, so practice ಮಾಡಿ, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ತುಂಬಾ ಸಲ ಕೇಳಿದ್ದಾರೆ, ಮೊನ್ನೆ ಸಪ್ಲಿಮೆಂಟರಿ ಅಲ್ಲಿ ಕೂಡ ಕೇಳಿರೋದು ಇದನ್ನ. ಸೊ ಸಪ್ಲಿಮೆಂಟರಿ ಅಲ್ಲಿ ಎಷ್ಟೊಂದು ಲೆಂತ್ ಕೇಳಿದ್ದಾರೆ, right? ಸೊ ಈ ಎಕ್ಸಾಂಪಲ್ ಕೂಡ ಇವೆರಡರಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಇದ್ದೇ ಇರುತ್ತೆ, ಸೊ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. So current electricity ಅಲ್ಲಿ ನಾವು 11 ಮಾರ್ಕ್ಸ್ ಚಾಪ್ಟರ್ ಇರೋದ್ರಿಂದ ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ, ಜೊತೆಗೆ ಡಿರೈವೇಷನ್ ಕೂಡ ಇರುತ್ತೆ. ಸೊ ಎರಡು ಬರೋದ್ರಿಂದ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ ಇದು. So next sixth question. So ಇದು ಸಿಂಪಲ್ ಇದೆ. Deduce the condition for the balance of Wheatstone bridge using Kirchhoff law. Right? So Wheatstone bridge means we need to construct one Wheatstone bridge. So this is in the rhombus shape. So Wheatstone bridge consists of 4 resistance, right? So naming these as A, B, C, D, right? So opposite ends of the opposite terminals we connected to the external source, that is for the battery, right? So that means in between point A and C we are connected to the external source, that is for the battery V. So as we connected this, so current I is flowing in the circuit. The remaining other 2 opposite sides are connected with the galvanometer, right? So this is the construction of the Wheatstone bridge, right? So now applying Kirchhoff. So again I3 is the current which is flowing in the resistance R3 and I4 is the resistance, current which is flowing in the resistance R4. So again, we getting the current I. So applying Kirchhoff's current law at junction A. So E point ಅಲ್ಲಿ Kirchhoff current law apply ಮಾಡಿದ್ರೆ, so inside of the current ಎರಡು divide ಆಗ್ತಿರೋದ್ರಿಂದ we can write I is equals to I1 plus I2. Calling this one as first equation, right? So next, applying Kirchhoff's current law at junction B. So E junction alli ನಾವು Kirchhoff's current law apply ಮಾಡಿದ್ರೆ, so I1 is going in and IG and I3 are leaving the junction. So ಇದು inside ಹೋಗ್ತಾ ಇದೆ, I3 ಮತ್ತೆ IG ಎರಡು ಏನಾಗಿದೆ ಹೊರಗಡೆ ಬರ್ತಾ ಇದೆ. So I1 that is equals to IG plus I3. So from this we can relate I3 is equals to I1 minus IG, calling this one as second equation, right? So here also we can directly write I1 minus IG. So next, same, applying KCL. So Kirchhoff current law at junction D. So that means here, so current inside ಹೋಗ್ತಾ ಇರೋದು I2 ಮತ್ತೆ IG. So these two are currents meeting at the junction. So these two are moving towards the junction and I4 is leaving the junction, right? So from this we can write I2 plus IG, that is equals to I4, right? So calling this one as third equation. So I4 na ನಾವು ಏನು ಬರ್ಕೋಬಹುದು, I2 plus IG, right? So next, apply Kirchhoff voltage law to the mesh A, B, D, A. So next, ಇದಿಷ್ಟು ಏನಾಯ್ತು ನಮಗೆ Kirchhoff current law. So next apply ಮಾಡ್ತಾ ಇರೋದು Kirchhoff voltage law, or we call that one as KVL, Kirchhoff voltage law to the mesh A, B, D, A. So this is in the clockwise direction. So ಇದನ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂತಿರೋ ಡೈರೆಕ್ಷನ್. ಸೊ ಯುವರ್ ವಿಶ್ ಇತ್ತು ಅಂದ್ರೆ ಇದನ್ನ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಆದ್ರೂ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬಹುದು, ಅದು ನಿಮಗೆ ಬಿಟ್ಟಿದ್ದು. ಸೊ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಇಲ್ಲಿ ನೇಮ್ ಏನಾಗಬೇಕು, ನಮಗೆ ಚೇಂಜ್ ಆಗಬೇಕು ಟು ದ ಮೆಶ್ ಎ ಡಿ ಬಿ ಎ. ಸೊ ಅದು ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್, ರೈಟ್? ಸೊ ಎರಡು ಮೆಶ್ ಕೂಡ ನಾವು ಡೈರೆಕ್ಷನ್ ಅನ್ನು ತಗೋಬೇಕು, ರೈಟ್? So first apply Kirchhoff voltage law to the mesh ABCD. That means Kirchhoff voltage law ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, so sum of algebraic sum of the IR product is equals to the sum of the EMF in the mesh, right? So that gives what the definition of the Kirchhoff voltage law. So ಇಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ್ದು ವೋಲ್ಟೇಜ್ ಇಲ್ಲ ಈ ಮೆಶ್ ಅಲ್ಲಿ. So voltage ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ. Only the relation we need to write the here is IR product, that is summation of IR product, right? So ಇಲ್ಲಿ ನೆನಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು, ನಾವು ತಗೊಂಡಿರೋ ಡೈರೆಕ್ಷನ್ ಮತ್ತೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿರೋ ಡೈರೆಕ್ಷನ್ ಇತ್ತು ಅಂದ್ರೆ ಐಆರ್ ಪ್ರಾಡಕ್ಟ್ ಯಾವಾಗಲೂ ನಾವು ಮೈನಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಕೆಲವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಇದ್ರೆ ಪಾಸಿಟಿವ್ ತಗೊಂಡಿದ್ದಾರೆ, ಬಟ್ ನಮಗೆ NCERT ಸಿಲೆಬಸ್ ಪ್ರಕಾರ ತಗೊಂಡ್ರೆ ಸೊ ಸ್ಟಾರ್ಟ್ಸ್ ವಿತ್ ಮೈನಸ್, ರೈಟ್? ಸೊ ಸ್ಟಾರ್ಟ್ಸ್ ಫ್ರಮ್ A B D A. ಸೊ ನಾವು ತಗೊಂಡಿರೋದು ಕೂಡ ಕ್ಲಾಕ್ ವೈಸ್, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರೋದು ಕೂಡ ಕ್ಲಾಕ್ ವೈಸ್. ಸೊ ದ ಫಸ್ಟ್ ರಿಲೇಷನ್ ಐಆರ್ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಮೈನಸ್ I1 R1, right? So here also current direction is there, so in that same direction ನಾವು ತಗೊಂತಾ ಇದೀವಿ. So resistance is G, so again minus Ig into G, right? So same direction idre minus ತಗೊಂಡಿದೀವಿ. So opposite direction idre plus ತಗೋಬೇಕು. So ನಾವು ತಗೊಂಡಿರೋ direction ಈ ತರ ಇದೆ, but current flow ಆಗ್ತಾ ಇರೋದು opposite ಇದೆ. That's why IR product here is plus I2 R2, that is equals to 0. Why 0? Because there is no cells in this mesh. So ಈ loop ಅಲ್ಲಿ ಯಾವುದೇ ತರದ cell ಇಲ್ಲ. So ಅದಕ್ಕೋಸ್ಕರ that is equals to 0, right? So calling this one as fourth equation, right? So next, applying Kirchhoff voltage law to the mesh. So idu ee direction alli ತಗೊಂಡಿರೋದ್ರಿಂದ B D C B. So this is the mesh direction. So now consider ಮಾಡ್ಕೊಂಡಿರೋ loop direction. So here also current flow ಆಗ್ತಾ ಇರೋ direction, ನಾವು ತಗೊಂಡಿರೋ direction ಎರಡು ಸೇಮ್ ಇದೆ. So that's why we take that one as minus Ig into G, right? So ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ, ಕರೆಂಟ್ ಹೋಗ್ತಾ ಇರೋ ಡೈರೆಕ್ಷನ್ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿರೋ ಡೈರೆಕ್ಷನ್ ಎರಡು ಸೇಮ್ ಇದೆ. ಸೊ ಅಗೇನ್ ಹಿಯರ್ ಮೈನಸ್ I4 into R4 ಅಂತ ಅನ್ನೋದು ಬರ್ಕೊಳ್ಳಿ, ಅಥವಾ ಡೈರೆಕ್ಟ್ ಆಗಿ I2 plus Ig into R4 ಅಂತ ಅನ್ನೋದು ಬರ್ಕೊಳ್ಳಿ. ದಟ್ ಈಸ್ ಫ್ರಮ್ ದ ರಿಲೇಷನ್ 3, ರೈಟ್? ಸೊ ಮೈನಸ್ I2 plus Ig into R4, right? So current opposite direction ಅಲ್ಲಿ ಇದೆ, ನಾವು ತಗೊಂಡಿರೋ ಡೈರೆಕ್ಷನ್ ಗೆ. ಸೊ ಹಿಯರ್ ವಿ ಗೆಟಿಂಗ್ plus I1 minus Ig into R3, that is equals to 0. So calling this one as fifth equation. So if Wheatstone bridge balance ಆಗಿರಬೇಕು ಅಂದ್ರೆ the current flowing across the galvanometer is 0, right? So ಇದು ತುಂಬಾ important for balancing condition. So Wheatstone bridge ನಮಗೆ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಆಗಿರಬೇಕು ಅಂದ್ರೆ, so condition ಏನಿದೆ, the current which is flowing through the galvanometer is 0. So that is Ig is equals to 0. So ಈ ಕಂಡೀಷನ್ ನ 1 ಮಾರ್ಕ್ಸ್ ಗೂ ಕೇಳ್ತಾ ಇರ್ತಾರೆ. ಸೊ ಡಿರೈವೇಷನ್ ಅಲ್ಲಿ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಈ ಸ್ಟೆಪ್ ನೀವು ಬರೆದರೆ ಅಂದ್ರೆ ಈ ಡಿರೈವೇಷನ್ ಗೆ ಮೀನಿಂಗ್ಲೆಸ್, ರೈಟ್? ಸೊ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಸ್ಟೆಪ್. ಸೊ 1 ಮಾರ್ಕ್ಸ್ ಗೂ ಕೇಳ್ತಾ ಇರ್ತಾರೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕಂಟಿನ್ಯೂಯೇಷನ್ ಪಾರ್ಟ್ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, ರೈಟ್? ಸೊ when Ig is equals to 0, so equation 4 and equation 5 becomes, right? So equation 4 and 5 becomes, so every equation ಅಲ್ಲಿ ಏನೇನ್ ಚೇಂಜಸ್ ಆಗುತ್ತೆ, right? So Ig 0 ಆಗಿದಂಗೆ equation 4 ಅಲ್ಲಿ this term completely becomes 0, right? So Ig 0 into G is 0, so this whole term becomes 0. So we left only minus I1 R1 plus I2 R2, that is equals to 0. So we can shift this to RHS. So we can write, so I2 by I1, that is equals to R2 R1 by R2, right? So this is equation number 6. So next, come to equation 5. So equation 4 becomes equation 6 when Ig is equals to 0. So same apply for the equation 5 also. So here also we have Ig. So this whole term become 0. So Ig 0 plus I2, we getting I2 into R4. So here also Ig is 0. I1 minus 0 is I1, right? So from this we can write minus I2 R4 plus I1 R3, that is equals to 0, right? So I2 R4, that is equals to I1 R3, right? So I2 by I1, we can write that one as R3 by R4. So equation 7, right? So from equation 6 and 7, so LHS ಅಲ್ಲಿ ಎರಡು ratios same ಇದೆ, I2 by I1. So here also I2 by I1, right? So from equation 6 and 7, right? So from equation 6 and 7 we can write R1 by R2, that is equals to R3 by R4. So this is the balanced condition. So LHS same ಇರೋದ್ರಿಂದ we can equate the RHS. So RHS ನ equate ಮಾಡಿದ್ರೆ R1 by R2, that is equals to R3 by R4. That means the resistance R1 by R2 is equals to R3 by R4. So otherwise we can relate R1 by R3 is equals to R2 by R4, or R2 by R1 is equals to R4 by R3. So ಯಾವುದು ಬರೋದ್ರೂ ಕರೆಕ್ಟ್ ಆಗೇ ಇರುತ್ತೆ. right? So ಇದು ಕೂಡ ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಇದರಲ್ಲಿ ನೀವು ಸ್ಟೆಪ್ಸ್ ನ ರಿಡ್ಯೂಸ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಅಲ್ಲಿ ಚಾನ್ಸ್ ಇಲ್ಲ, ರೈಟ್? ಎಲ್ಲದನ್ನು ಬರೀಲೇಬೇಕು, ಬಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇದು. ಸೊ ಕೆಲವುದರಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಪ್ಲಸ್ I1 R1 ಪ್ಲಸ್ IG RG, ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದ್ರೆ ಮೈನಸ್ I2 R2 ಇದೆ. ಸೊ ಅದು ನಮಗೆ ಓಲ್ಡ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಮತ್ತೆ ಓಲ್ಡ್ ಮೆಥಡ್ಸ್ ಅಲ್ಲಿ ನಾವು ಅದೇ ತರ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಬಟ್ NCERT ರೂಲ್ಸ್ ಪ್ರಕಾರ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ ಇದನ್ನ ಏನು ನಾವು ಮೈನಸ್ ತಗೊಂತಾ ಇದೀವಿ ಅಂದ್ರೆ ಅಗೈನ್ ಕರೆಂಟ್ ಈಸ್ flowing from positive terminal to negative terminal, right? So but here current is flowing opposite, so negative ಇಂದ positive ಹೋಗ್ತಿದೆ, that's why we are taken minus. So ಅದಕ್ಕೂ ಕೂಡ ಒಂದು ರೂಲ್ ಇರೋದ್ರಿಂದ we can prefer this one, right? So confuse ಆಗಬೇಡಿ, ಕೆಲವು ಗೈಡ್ಸ್ ಅಲ್ಲಿ ಪ್ಲಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, so ರೂಲ್ ಪ್ರಕಾರ ಮೈನಸ್ ತಗೋಬೇಕು in the direction of current, right? So ಇದಿಷ್ಟು ಪಾರ್ಟ್ 4 ಅಲ್ಲಿ ಅಲ್ಲ, ಪಾರ್ಟ್ ಡಿ ಅಲ್ಲಿ 4th ಮೈನ್. ಸೊ 6 ಕ್ವೆಶ್ಚನ್ಸ್ ಇದಾವೆ. ಔಟ್ ಆಫ್ 6 ಕ್ವೆಶ್ಚನ್ಸ್ 3 ಕ್ವೆಶ್ಚನ್ಸ್ ಅಂತೂ ಇದ್ದೇ ಇರುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್ ಡಿ 5th ಮೈನ್. ಟೈಮ್ ತುಂಬಾ ಕಮ್ಮಿ ಇರೋದ್ರಿಂದ ಫಾಸ್ಟ್ ಆಗಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಪಾರ್ಟ್ ಡಿ 5th ಮೈನ್ ಅಲ್ಲಿ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ ಹೇಳ್ತೀನಿ. ಫಸ್ಟ್ ಕ್ವೆಶ್ಚನ್, ಸೆಕೆಂಡ್ ಕ್ವೆಶ್ಚನ್, ನೆಕ್ಸ್ಟ್ 4th ಕ್ವೆಶ್ಚನ್, ನೆಕ್ಸ್ಟ್ 5th ಕ್ವೆಶ್ಚನ್. ಸೊ 4 ಕ್ವೆಶ್ಚನ್ಸ್ ಇದೆ. ಥಿನ್ ಲೆನ್ಸಸ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅದು ನಮಗೆ 3 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೇಳ್ತಾರೆ. ಸೊ ಯಾವುದೋ 1 ಟೈಮ್ 2 ಟೈಮ್ ಅದನ್ನ 5 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ ಕೇಳಿರೋದ್ರಿಂದ, ರೈಟ್? ಸೊ ಅದನ್ನ 3 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ ರೆಫರ್ ಮಾಡಿ. ಸೊ ಇವಾಗ 5 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ ದೀಸ್ 4 questions. So 4 questions ಅಲ್ಲಿ 3 questions ನಾನು ಕೇಳ್ತೀನಿ, right? So 3 questions ಅಲ್ಲಿ you need to answer any 2 questions, right? So in that first one, deduce the relation between N, U, V and R. So ಕೆಲವು ಕ್ವೆಶ್ಚನ್ಸ್ ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಇದೇ ತರನೇ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡ್ತಾರೆ, ಆರ್ ದೇ ಆಸ್ಕ್ ಫಾರ್ ದ ರಿಫ್ರಾಕ್ಷನ್ ಅಟ್ ಎ ಸ್ಪೆರಿಕಲ್ ಸರ್ಫೇಸ್ ಅಂತಾನೆ ಕೇಳ್ತಾರೆ. obtain the expression for the refraction at spherical surface or obtain the relation for N, U, V and R, right? So N is the refractive index of the medium, U is the object distance, V is the image distance and R is the radius of curvature, right? So refraction at spherical surface, refraction at spherical surface. So ಇದು ray optics ಇಂದ ಬರೋದ್ರಿಂದ ಸೊ ರಿಫ್ಲೆಕ್ಷನ್ ಇಲ್ಲ. ಸೊ ಅಪ್ ಟು ರಿಫ್ಲೆಕ್ಷನ್ ಏನೇನ್ ಟಾಪಿಕ್ಸ್ ಇದಾವೆ ಅದೆಲ್ಲದನ್ನು ಮಿರರ್ ಫಾರ್ಮುಲಾ ಇರ್ಬೋದು, ಅದೆಲ್ಲದನ್ನು ಕೂಡ ಡಿಲೀಟ್ ಆಗಿದೆ. ಸೊ ಅದನ್ನ ಯಾವುದನ್ನು ಓದಬೇಡಿ. ಸೊ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ರಿಫ್ರಾಕ್ಷನ್ ಅಲ್ಲಿ ಲಾಸ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ, ರೈಟ್? ಸೊ ಅದರಲ್ಲಿ ಫಸ್ಟ್ ಡಿರೈವೇಶನ್ ಬಂದ್ಬಿಟ್ಟು ರಿಫ್ರಾಕ್ಷನ್ ಅಟ್ spherical surface, right? So consider one spherical surface x, y. So having the refractive index n1 and n2, right? So ಈ ಸೈಡ್ ಅಲ್ಲಿ ಏನು ನಮಗೆ spherical surface ಇದೆ, ಇದಿಷ್ಟು ಮೀಡಿಯಂ ಏನಿರುತ್ತೆ ನಮಗೆ ಸಪರೇಟ್ ಮೀಡಿಯಂ ಆಗಿರುತ್ತೆ. ಸೊ ಈ ಕಡೆ one ಮೀಡಿಯಂ ಇತ್ತು ಅಂದ್ರೆ inside the refracting surface we can take the refractive index as n2, where n1 and n2 are the refractive index of the two mediums, right? Drawing the principal axis, right, where P is the pole. So consider an object on the principal axis. So object na consider ಮಾಡ್ತೀವಿ, so that is represented by O, right? So taken incident rays, right? So two incident rays, after it gets refracted, so they will meet at point on the principal axis. We taken that one as I, where I is the image formed, O is the object, right? So it is refracted ray. So two incident rays and two refracted rays, right? So naming this one as M. So OM is the incident ray and MI is the refracted ray, right? OM is the incident ray and MI is the refracted ray, right? So drawing the normal at the point of incident, where M is the point of the incident. So here we are going to draw the normal. Normal means we are drawing one tangent. Onto that tangent, we need to draw one perpendicular. So ಇದನ್ನ regular class ಅಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ. So normal ಯಾವ ತರ draw ಮಾಡೋದು ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ M ಹತ್ರ ಒಂದು tangent ನ draw ಮಾಡ್ತೀವಿ. So ಈ tangent ಗೆ normal ಅಂದ್ರೆ perpendicular line draw ಮಾಡಿದ್ರೆ, so this perpendicular line gives what? The normal line. So this normal line is always passing through the center of curvature. So this point is C. So ಯಾವಾಗಲೂ ಎಲ್ಲಿಂದ ಪಾಸ್ ಆಗುತ್ತೆ ನಮಗೆ center of curvature ಇಂದ ಪಾಸ್ ಆಗುತ್ತೆ. Here the angle between incident ray and to the normal we call as angle of incident, and the angle between the refracted ray and to the normal ray we call that as angle of refraction, right? So from the point A, draw one perpendicular onto the principal axis, we call that one as N, right? So now take an angle that is alpha, beta and gamma. So U is the object distance, V is the image distance, R is the radius of curvature, right? So U is represented the object distance, V is the image distance, and R is the radius of curvature. So these two ಕೂಡ diagram. ಈ diagram ಅಲ್ಲಿ ಯಾವುದೇ ಒಂದು even arrow mark miss ಆಯ್ತು ಅಂದ್ರೂ ಕೂಡ ನಿಮಗೆ 0 marks ಸಿಗುತ್ತೆ. So ray diagrams ಅಲ್ಲಿ arrow mark ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. So ray diagrams ಇಂದ ನಾವು diagram ಬರೆಯೋದ್ರಿಂದ arrow mark ಮಿಸ್ ಆಯ್ತು, ಯಾವುದಾದ್ರೂ ಒಂದು arrow mark ಮಿಸ್ ಆಯ್ತು ಅಂದ್ರೂ ಕೂಡ ನಮಗೆ 0 marks, because ಕ್ವೆಶ್ಚನ್ ಪೇಪರ್ ಅಲ್ಲಿ ಸ್ಟಾರ್ಟಿಂಗ್ 3 ಪಾಯಿಂಟ್ಸ್ ಕ್ಲಿಯರ್ ಆಗಿ ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರೆ. ವಿತೌಟ್ ಎನಿ ಪ್ರಾಪರ್ ಡಯಾಗ್ರಾಮ್ ಇತ್ತು ಅಂದ್ರೆ ವಿಲ್ ನಾಟ್ ಕ್ಯಾರಿ ಎನಿ ಮಾರ್ಕ್ಸ್. ಸೊ ವಿಲ್ ನಾಟ್ ಎನಿ ಕ್ಯಾರಿ ಮಾರ್ಕ್ಸ್ ಅಂದ್ರೆ 0 ಮಾರ್ಕ್ಸ್ ಅಂತ. ಸೊ ಅಲ್ಲಿ ನಿಮಗೆ 1 ಮಾರ್ಕ್ಸ್ ಕೊಟ್ಟರೆ 2 ಮಾರ್ಕ್ಸ್ ಕೊಟ್ಟರೆ ಅಂತ ಏನು ಮಾಡೋದಿಲ್ಲ, ರೈಟ್? ಸೊ ಡಯಾಗ್ರಾಮ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ನೇಮ್, ರೈಟ್? ಸೊ ಇದಿಷ್ಟು ಇತ್ತು ಅಂದ್ರೆ ಡಿರೈವೇಷನ್ ಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ನೀವು ಯಾವುದೋ ಒಂದು ಲೇಬಲಿಂಗ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀರಾ, ಡಿರೈವ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಬೇರೆ ಏನೋ ಟರ್ಮ್ಸ್ ಬರ್ತಿರ್ತೀರಾ, ಇದಕ್ಕೂ ಅಲ್ಲಿ ಮ್ಯಾಚ್ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಅಗೇನ್ ಡಿರೈವೇಷನ್ ಏನಾಗುತ್ತೆ, ರಾಂಗ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ consider triangle. So consider the triangle. So your triangle consider ಮಾಡೋದು, right? So this triangle MOC, right? So otherwise I will write here. So MOC. Right, so here is the angle alpha, angle I, and here is the angle gamma. So example idu necessity illa, so nimge artha agli anta heli ಬರೀತಾರೆ, right? So consider the triangle MOC, right? So again from the geometry, exterior angle is equals to sum of opposite interior angle. So ಇಲ್ಲಿಂದ ಬಂತು ಅಂದ್ರೆ ಮ್ಯಾಥ್ಸ್ ಇಂದ ಬಂದಿದೆ, ಫ್ರಮ್ ದ ಜಿಯೋಮೆಟ್ರಿ. ಸೊ ಟ್ರಯಾಂಗಲ್ ರೂಲ್ಸ್. ಸೊ ಏನ್ ಹೇಳ್ತಿದೆ, ಎಕ್ಸ್ಟೀರಿಯರ್ ಆಂಗಲ್. ಸೊ ವಿ ಕನ್ಸಿಡರ್ ದಿಸ್ ಟ್ರಯಾಂಗಲ್ MOC. ಸೊ ಇದರಲ್ಲಿ ಎಕ್ಸ್ಟೀರಿಯರ್ ಆಂಗಲ್ ನಥಿಂಗ್ ಬಟ್ ಔಟ್ಸೈಡ್ ಆಂಗಲ್. ಔಟ್ಸೈಡ್ ಆಂಗಲ್ ಯಾವುದಿದೆ ನಮಗೆ? I. Angle of incidence is the exterior angle I, that is equals to sum of opposite interior angles. So ಈ angle I ಗೆ opposite ಯಾವ angles ಇದಾವೆ? alpha ಮತ್ತೆ gamma ಇದೆ. So these are the two opposite angles and these two will be added, right? So that is sum. That's why we can take alpha plus gamma, calling this one as first equation, right? So next, again from triangle, considering one more triangle, right? So that triangle is MCI. So here we have MCI, right? So here we have R, beta, and here we have gamma, right? So considering the triangle MCI. So from the triangle, again by the same rule, exterior angle is equals to sum of opposite interior angle. So here exterior angle is gamma. So ನೀವು consider ಮಾಡಿರೋ ಈ triangle ಅಲ್ಲಿ ಹೊರಗಡೆ ಇರೋ angle ಯಾವುದು ಅಂದ್ರೆ gamma. ಇದು ಯಾವುದು ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ opposite angles ಗೆ sum ಗೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. So from this we can write gamma that is equals to r plus beta, right? So from this we can write r is equals to gamma minus beta, calling this one as second equation, right? So next, from Snell's law, so Snell's law says that refractive index of a medium 8 to 1, that is equals to ratio of the sine of angle of incidence to the sine of angle of refraction, sin I by sin R. So this is from the Snell's law. So n2 1 we can write that one as n2 by n1. So this is by the relation of the refractive index. So refractive index n2 1 ನಾವು ಯಾವ ತರ ಬರೀತೀವಿ n2 by n1 ಅಂತ ಬರೀತೀವಿ, ಅದು ಯಾವುದು ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ sin I by sin R, right? So next condition for small angle. So ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿರೋ ಎಲ್ಲ ಆಂಗಲ್ಸ್ I, R, alpha, gamma, beta ಇವೆಲ್ಲವೂ ಕೂಡ ಸ್ಮಾಲ್ ಆಂಗಲ್ಸ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡುತ್ತೆ. ಸೊ ಸ್ಮಾಲ್ ಆಂಗಲ್ಸ್ ಯಾವಾಗಿರುತ್ತೆ ಅಂದ್ರೆ when the object is at a larger distance. ಸೊ ಲಾರ್ಜರ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಇದ್ದು, ಸೊ ಲಾರ್ಜರ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇಮೇಜ್ ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ ಫಾರ್ಮ್ ಆಗೋ ಆಂಗಲ್ಸ್ ಏನಾಗುತ್ತೆ ನಮಗೆ ತುಂಬಾ ಚಿಕ್ಕದಾಗಿರುತ್ತೆ. ಸೊ ತುಂಬಾ ಚಿಕ್ಕದಾಯ್ತು ಅಂದ್ರೆ ಈ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ P and N is almost same, right? For small angles P is approximately equals to N. That means it becomes straight. So small angles consider ಮಾಡಿದ್ರೆ ಎರಡು ಏನಾಗುತ್ತೆ ಸೇಮ್ ಆಗುತ್ತೆ. And also the angles sin I is approximately equals to I and sin R is approximately equals to R, right? So it is only applicable only in case of sin and tan. So ನೀವು cos ಗೆ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, cot ಗೆ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಅದು wrong ಆಗುತ್ತೆ. So only this is applicable in case of sine and tangent, right? So this Snell's law become n2 by n1 that is equals to I divided by R. So cross multiplying these two, n2 R that is equals to n1 I. So we have the values of R and I. So substituting here, n2 into gamma minus beta that is equals to n1 into alpha plus gamma, right? So this is from equation 1 and 2. So now we need the values of gamma, beta, alpha, right? So again considering from triangle, right? So from considering the triangle M O N or M O P, because P is almost equals to N. So P plus N baribodu N baribodu, right? Because we are considering the small angles. So it throughout the derivation applicable agudirinda. So from the triangle O M P, right? So here we have alpha. So considering small angles, tan alpha is almost equals to alpha that is equals to opposite side by adjacent side. So opposite side is MP, adjacent side by OP, right? So in curve is there, curve kuda matte straight line ಎರಡು ಸೇಮ್ ಆಗುತ್ತೆ because P is equals to N. So ನಿಮಗೆ ಮತ್ತೆ ಇಲ್ಲಿ ಬರ್ದು ಸ್ಟೆಪ್ಸ್ ಜಾಸ್ತಿ ಆಗೋದ್ರಿಂದ ರೆಡ್ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ so ಇಲ್ಲೇ ಕನ್ಸಿಡರ್ ಮಾಡೋದ್ರಿಂದ so directly we can write, right? So similarly from triangle CMP, right? So from this triangle CMP, so here we having gamma, right? So gamma is equals to opposite MP divided by PC, right? So similarly from triangle IMP, naming ಏನು ಕೊಟ್ಟಿರ್ತೀರೋ ಅದನ್ನ ಬರ್ಕೊಳ್ಳಿ, right? So that is MP divided by PI. So now substituting the values of alpha, beta and gamma, right? So into gamma value is MP by PC minus beta value MP by PI that is equals to N1 alpha value MP by OP plus gamma value MP by PC, right? So in LHS terms and in also RHS terms MP ಎಲ್ಲದರಲ್ಲೂ ಕಾಮನ್ ಇದೆ, so we can take outside and we can cancel. So ಅದನ್ನ ಹೊರಗಡೆ ತಗೊಂಡು cancel ಕೂಡ ಮಾಡಬಹುದು. Right? So we get relation into 1 by PC minus 1 by PI, that is equals to N1 into 1 by OP plus 1 by PC. Now rearranging the terms. So illi PC ide matte illi PC ide. So we can shift this to LHS. So N2 by PC minus N1 by PC, that is equals to N1 by OP plus N2 by PI. Right? So now by using sign convention, so ಇದಕ್ಕೆ ಒಂದು equation ಬಂದ್ರೆ fourth equation, fourth or third equation, right? So object ಇಂದ ನಾವು ಎಲ್ಲ ಡಿಸ್ಟೆನ್ಸಸ್ ಮೆಜರ್ ಮಾಡಿರೋದು ಪೋಲ್ ಇಂದ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ರೇಗೆ ಆಪೋಸಿಟ್ ಆಗಿ ಮೆಜರ್ ಮಾಡ್ತಿರೋದ್ರಿಂದ ನಮಗೆ OP is equals to minus U and PI is equals to in the direction of ಮೆಜರ್ ಮಾಡ್ತಿರೋದ್ರಿಂದ plus B and PC is equals to plus R. So substitute these values in equation 3, right? So N2 minus N1 divided by PC common is that, so that is R, that is equals to N1 by OP. OP is minus U, right? So minus N1 by U plus N2 by B. So rearrange ಮಾಡಿ ಬರೋದ್ರೆ N2 by B minus N1 by U, that is equals to N2 minus N1 by R. So this is the relation between N, U, B and R. So ಇಷ್ಟೇ ಟರ್ಮ್ಸ್ ಇರಬೇಕು. So N ಮತ್ತೆ U R B, right? So ಏನಂದ್ರೆ refractive index of two medium into 1. So ಇದು ಯಾವಾಗ represent ಮಾಡಿದ್ರೆ into 1 ಅಂತ represent ಮಾಡ್ತಾರೆ, right? So ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಡಿರೈವೇಷನ್. So 2018 ಅಲ್ಲಿ so ಈ ರಿಲೇಷನ್ ಆಫ್ ಡಿರೈವ್ ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ರು in place of R they given theta, right? So in place of R ಬದಲು theta ಅಂತ ಕೊಟ್ಟಿದ್ರು. So ಕ್ವೆಶ್ಚನ್ ರಾಂಗ್ ಇದೆ ಅಂತ ಕ್ವೆಶ್ಚನ್ ಬಿಟ್ಟಿದ್ರು, ಬಟ್ ಗ್ರೇಸ್ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ಲಿಲ್ಲ. So ನಿಮಗೆ ಗೊತ್ತಿದೆ ರಿಲೇಷನ್ ಅಲ್ಲಿ R ಇರುತ್ತೆ ಅಂತ. ಸೊ ಡಿರೈವ್ ಮಾಡೋದನ್ನ ನೀವು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಡಿರೈವ್ ಮಾಡಿ, ರೈಟ್? ಸೊ ಕ್ವೆಶ್ಚನ್ ರಾಂಗ್ ಇದೆ ಗ್ರೇಸ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ನೀವೇ ಮಾರ್ಕ್ಸ್ ಕಳ್ಕೊಂತೀರಾ, ರೈಟ್? So remaining we will discuss in our next class, right? Thank you.